kids, we're going to go ahead and we're going to start off the entire unit on how to balance chemical equations. In order to learn how to balance chemical equations, obviously I'll have something over on the left side. So let's say A plus B produces AB. Now here's where this comes in tricky. Obviously I can get a little more complex than simply an A or B. I could have this entire thing here on the left side, or this entire thing here on the left side. So what we've got to learn how to do today is we've got to learn to figure out how to isolate and figure out simply what's on the left side so that I can balance it with what's on the right side. Which means if you can't figure out how many of each specific atom there are in each of these 15 things, obviously we need to practice that. So we'll start off with number 1, 4 magnesium chlorides. This 4 distributes to the Mg, so I've got 4 of those. And it distributes to the Cl, but I've got Cl2, so I'm going to have 4 times 2 gives me 8 of those. Okay. Working on to number 2. This 2 distributes to everything that happens to be inside the parentheses, but it does not distribute to the Be. So we've only got one Be, but I happen to have 2 times 1 Ns, and I happen to have 2 times 3 Os. 2 times 3 gives me 6. And essentially what that is I've got a Be here, and an NO3, and an NO3, and this Be is going to give an electron to each NO3. So within that I've got 2 Ns, and 3 plus 3 gives me 6 oxygens, which means I already screwed up. That N should be 2. Okay? So hopefully you caught on to that and saw that error before I did. In terms of this 2, it does the exact same thing as the last problem. If I've got 4 Be NO3 2, this 2 distributes inside the parentheses, but it stops at the parentheses. This 4, however, distributes to everything until you get to a plus sign. So it's going to go to the Be, the N, and the O. So I've got 4 Be's. I happen to have 4 times 1 N's times 2. So 4 times 1 gives me 4. 4 times 2 gives me 8. So I've got 8 nitrogens. And then for the oxygens, I've got 4 times 3, which gives me 12. 12 times 2 gives me 24 oxygens. Okay? So this is your first real hint here as to what distributes in different directions. The 4, being a coefficient, will distribute to everything until you get to a plus sign, like this guy. This subscript here, outside of the parentheses, will distribute only to those polyatomic, only those that are part of the polyatomic, the NO3. Okay. Moving on to our next set. We've got MgCl2 plus Li2CO3. Alright, so I don't see any coefficients, which means I don't have to multiply in the front. So it's simply count them out. I've got 1 Mg, I've got 2 Cl's, I've got 2 Li's, I've got 1 C, and I've got 3 O's. Nice and simple here. Number 5 is where we get tricky again, but for a different reason. This time I've got to go through and make sure that I am taking into account things that happen to be both on the left and the right side of this plus. Okay, because I happen to have 9 O2s there, but 6 oxygens there. So we'll keep that in mind when we get back to this stuff. Carbons are nice and simple. I just have C6. 6 of those. I'll worry about the oxygens later. My hydrogens, looking at this whole thing, only have one place where there is hydrogen, so there are 12 hydrogens. And now the oxygens, I've got to worry about the left and the right side of the plus sign. So I've got 6 of them here on the left, plus 9O2 gives me 18 here. 6 plus 18 gives me a nice little 24 oxygens. Okay? And again, if you're not able to do something that looks like this, going through and figuring out what would be on the right side of a produced produces or yields, or an arrow, is going to be really, really, really hard to balance out with the left side if you can't figure out what's on just the simply left or the right. And looking at number 6, 6 again is going to be the same kind of thing. I happen to have oxygens on the left and oxygens on the right, but this problem also gets a little tricky in the fact that I've got coefficients 6 and 6. So let's try this out. I have 6 times C, or 6 times 1 gives me 6 carbons. I'll worry about the oxygens later because those are going to be the most complex. I have 6 times H2, which gives me 12 hydrogens. So from here, all I've got to do is figure out how many oxygens. 6 times 2 gives me 12 there. And then 6 times 1, because there's no subscript here, 6 times 1 gives me 6. So 12 plus 6 gives me 18 oxygens. Alright, moving our way down to 7. We'll shift our way down for 7 through 14, 7 through 13. And we'll start off again here. I've got Pb plus FeSO4, no coefficients, nothing crazy going on here, so it's simply count them out. 1 Pb, 4 oxygens, because we've got that subscript 4, it only relates to the oxygen here, because there's no parentheses. 1 S and 1 Fe. Really, really simple. Again, the same basic idea for number 8, CaO plus CO2. The only weird guy is I've got an oxygen here and an oxygen here, so I know I'm going to take that 1 plus that 2 to give me 3 oxygens, 1 calcium, 1 carbon. Really, really, really simple. Make that one bigger. For number 9, P4 plus 3O2. I know that there's nothing crazy going on with that P. There's simply 4 of them. And in terms of the oxygen, it's going to be 3 O2 molecules. So we're going to go through and we're going to have 6 of those. And again, what that's showing is I've got an oxygen, an oxygen, and an oxygen. And again, obviously there would be valence electrons on each of those. So we'll just say that times 3. Okay. Again, look at number 10. Number 10, I happen to have a coefficient before all of that P2O3. So I'm going to take this 2 and multiply by P2. Gives me a 4. And that 2 distributes to O3 as well. So 2 times 3 gives me 6. And I guess the reason I went through and I threw 9 and 10 together is because you hopefully see that they both end in P4O6. But there are multiple different ways that I can go about getting that P4O6. And so realistically, I could set up an equation that looks like that, where I've got P4 plus 3O2 produces 2 P2O3. And we would consider this whole thing right now balanced, because they have the same number of P's and the same number of O's on each side. And this is our end goal here, is going through and being able to balance equations. But I can't do that if I can't figure out what's on one side of an equation. Moving down to number 11, we start getting, again, a little tricky because we throw coefficients into here. This 2 is going to refer to the Rb, the rubidium, the N, and the O3. But this is, again, kind of easy because Be and Fe2 really don't relate to these at all. So I've simply got 2 rubidiums. 2 times 3 gives me 6 oxygens. I've got 2 times 1 gives me 2 nitrogens, 1 Be, and that subscript of 2 only corresponds to that F, so I've got 2 Fs. Moving on to number 12, this guy gets a little trickier. We've got 2 corresponding to the Rb and the F. And this coefficient, or subscript of 2 only relates to what's inside the parentheses, so only to the polyatomic NO3. It does not relate to the beryllium. Okay? So let's look our way through this. For the Rb, I've got 2 as a coefficient for the Rb, so I've got 2 of those. Oxygen, I have 2 O3s, which gives me 2 times 3 is 6. For nitrogens, I've got 2 times 1, gives me 2. Be, there's nothing in front of and no subscript relates to it, so there's 1 BE. And again, F has a coefficient of 2 in front of it. So hopefully for 11 and 12 you saw the same basic idea that we talked about for 9 and 10. These are both equaling the same things in terms of their general numbers of each atom, but they are set up in different ways, and that's hopefully something that I hope that you are starting to pick up. And working through the final one before we shift down, we've got 2 silver nitride plus copper. This 2 is going to go through and distribute to the Ag, to the N, and to the O3. So I've got 2 times 1 gives me 2 silvers. I happen to have 2 times 3 gives me 6 oxygens, and 2 times 1 gives me 2 nitrogens. And then obviously this copper is all by itself, and I get 1 of those. Let's go ahead and clear, and shift down to the last set. I believe we just did number 13 last, yes. So we'll move our way up to 14. CuNO3,2, so I know that there's no coefficient. Nothing's going to relate to this copper, but this 2 relates to everything inside that parentheses, so the NO3. And this 2Ag, simply that 2 relates to this guy. So looking at that, I'm going to have 2 silvers. My oxygens, I'm going to have 2 as that subscript, related to the 3 as that subscript, so 2 times 3 gives me 6. My nitrogen, 2 times 1, and nothing relates to this copper. The only thing that would relate to a copper would be a coefficient that happens to be right there, but we don't have one, so there's 1 copper. And again, I already can tell, apparently Mr. Banker went through, and your nitrogens should not be 1. 2 times 1 gives us 2. It's only twice this video that I've screwed up. Number 15. We got 4 left and 3 minutes. I do not have any other carbons, do not have any other hydrogens. I do have oxygen here and oxygen there, so that's what I need to kind of keep my eye out for. So I've got 6 hydrogens. Wow. I have 3 carbons. I have 6 hydrogens. 3 carbons, 6 hydrogens. But now I need to figure out my oxygens. I've got 1 here, and I happen to have 4 times 2 gives me 8 of them here. So I've got 9 total oxygens. Looking at number 16, we have oxygens on both sides, which is going to be tricky, and I've got coefficients of 3 on each side. So we're going to go through and distribute that 3 all the way up until you hit plus sign. So I've got 3 CO2s and 3 H2Os. So start this off. 3 C's, 3, plus my 3 H2s, 3 times 2 gives me 6 of those. And then all we gotta do is figure out the oxygens. 3 O2s gives me 6 of those here, and 3 O's gives me 3 of those here. 6 plus 3 gives me 9 oxygens. 2 problems left. Work our way down to number 17. Again, 17 doesn't look like it has anything really crazy. We do have a hydrogen on the left and a hydrogen on the right of that plus, so that's going to be the only tricky thing to worry about. So that coefficient of 2 means we've got 2 C5s, 10 of those, and I'll worry about the oxygens for now. The 2 does not relate at all because of that plus sign, so I've simply got 1 oxygen. And then the only thing left for this guy would be how many hydrogens. I have 2 times H5, 10 of those, and then H2, 2 of those. 10 plus 2 gives us 12. And then our final set here would be FC5H52. This 2 distributes to the H, distributes to the C, which means I've got 10 C's and 10 H's, but the 2 does not distribute to the Fe, so I have only 1 of those. The only other tricky thing I could really do is if I threw something like a 4 in front of this. The 4 would distribute to everything, which means instead of going through and having 1 Fe, I'd have 4 of them. Instead of having 10 C's, 2 times 5 gives me 10, times 4 gives me 40. And then I'd also have 40 H's. If you can do that, you can